Okay, welcome students. In this video we're going to talk about the gas laws. We're going to introduce the gas laws. We're going to study one of them today. The one that we're going to study is, the first one's Boyle's law. But for gas laws, if you're watching the video, please be following along with your guided notes and filling them out as we go through these slides. We're going to study the following gas laws. We're going to study Boyle's law today, but that's just one of them. Boyle's law. Another gas law we're going to study is Charles' law. That'll be next time. We're also going to study Avogadro's law. Hey, have you guys remember this name, Avogadro?
6.0.
Yeah, it's Avogadro's number, right? It's the same guy. That's kind of how he was working with the gas phase, with gases, and determine that. So Avogadro's law. And then finally we're going to study the ideal gas law. Okay, this one's the most important. We're saving it for the end for reasons that I'll explain later. The ideal gas law. Okay, so there's four of them. Four of these different gas laws. But each of these laws is a mathematical expression that explains the properties of gases. So each one is a mathematical expression, and it explains the properties of gases. So each one of these is going to have their own kind of equation that goes along with them. We're going to learn them. Okay, let's start with the first gas law. It's Boyle's law. Robert Boyle was an Irish chemist, lived in the 1600s, and he was the first person to perform quantitative experiments on gases. What does it mean, guys? Quantitative? Sort of. So, we talked about it in the introduction to chemistry chapter. There's two types of data. There's qualitative and quantitative. What does quantitative mean? Yeah, it has to do with numbers. Guys, make that note. Quantitative deals with numbers. So if you go to the store and you get a quantity of 5 candy bars, that's a quantity. It's a quantity because it's a number. You got 5 of them. Would this be quantitative data or qualitative? Nick has a red hoodie on. That's qualitative. You can't measure it with a number, red. I guess you can. You can quantify colors. But that wasn't a quantifiable data. He's wearing a red hoodie. That's qualitative. Now what about this one? The tree is 20 meters tall. That's quantitative. And so Robert Boyle was the first person to do quantitative experiments on gases. So he kept numbers on them. Well, what did he study? Boyle studied the relationship between the pressure on a gas and its volume. So he looked at pressure and volume and how they affected each other. Pressure and volume. And Boyle found that there is an inverse relationship between pressure and volume. So he found that there is an inverse relationship between pressure and volume. You're going to see that a lot in this chapter. We're going to talk about what kind of relationship they have. Let's go back. Let's explain the difference between a direct relationship and an inverse relationship. In a direct relationship, which isn't this one, if one variable goes up, what happens to the other variable? It also goes up. Okay? You might want to make these notes. Okay? This is going to be kind of important to understand. Also, in a direct relationship, if one goes down, what happens to the other one? Well, it also goes down. See how they're directly related to each other? This is known as a direct relationship. Now, with Boyle's law, what we're talking about is an inverse. An inverse relationship. So in an inverse relationship, if one variable goes up, what happens to the other one? It goes down. Okay? Well, what if we do it vice versa of that? What if the first variable goes down? Then the second one has to do what? Goes up. Oops. Okay, see how they're inversely related? If one goes up, the other one goes down. That's what Boyle's law is. So, if we put that into words, this means that as the pressure on a gas goes up, so if pressure goes up, what happens to volume? Goes down. So if pressure on a gas goes up, the volume would have to go down. Now, what if you said it vice versa of that? What if the pressure goes down? The volume has to go up. Okay. I hope you're following along with your notes. You filling this in? Okay. Okay, so Boyle's law. We said it's a mathematical expression. Here's the mathematical equation for Boyle's law. PV equals K. PV equals K. What do you think the P stands for here, guys? Pressure. And V stands for what, guys? Volume. And K is a constant. Okay, it can be any number, but it stays constant. If K stays constant, say it's, I don't know, say it's 10. Okay, say that constant there is 10. If pressure goes up, what would volume have to do in order for it to stay 10? It would have to go down. Okay, and vice versa. So that's how they're inversely related. They're inversely related. All right, in other words, you could say it also like this. Volume of the gas is equal to 1 over the pressure. You like the first one better? Okay. Well, Boyle graphed the volume of a gas at different pressures. And here's what he came up with. He put volume on the y-axis. That was his dependent variable. The independent variable he put on the x-axis was pressure. You're supposed to draw this graph in your notes. So take a second to jot this down. Volume is on the y-axis. Make a quick graph of this. But what he noticed is when pressure was very low, what was volume? High. Very high. And then it just kind of made this kind of a graph. So as pressure increased, what happened to volume? It decreased. Okay. When you see a graph that looks like this is an inverse function. As one goes up, the other one goes down. You will always get a graph that looks like this. Okay. So, one common use of Boyle's law is to predict a new volume of a gas when the pressure is changed. So if we have a gas and it's at a certain pressure, we can change its pressure. But will that affect its volume? Yes. Yes. And Boyle's law can also be written like this, and this is probably the equation that we're going to use the most with Boyle's law. Okay? P1 times V1 is equal to P2 times V2. Again, let's explain it. What does the P stand for? Pressure. What's V stand for? Volume. Well, now we just got to explain what's the difference between the 1s on the left side and the 2s on the right side. 1 means that's what it was initially. So pressure initial times volume initial is equal, what does a 2 mean? 2 means final. Please make these notes in your books. P2 is what the pressure is final, and V2 is what the volume is final. Okay, we're going to use this equation a lot. I'm going to show you how to use it. Okay? So summary of Boyle's law real fast, and then we'll use that equation. Summary. So there's an inverse relationship between the pressure and volume of a gas. There's an inverse. As one goes up, the other one goes down. It's an inverse relationship between pressure and volume. Number 2, as the pressure on a gas goes up, so you put more pressure on it, the volume of the gas goes down, and vice versa. Volume times pressure is equal to a constant. Volume times pressure is equal to a constant. Another way of saying that is that P1 times V1 is equal to P2 times V2. Okay. If you're going to remember one thing from Boyle's law, it's this equation right here. P1 times V1 equals P2 times V2. I'm going to show you a practice problem. We're going to go through how to use that equation. It's pretty simple, but there's a few things that you've got to be aware of. Okay. So let's do it. Practice problem number 4 in your book. So follow along. Let's read through it first, and then we'll solve it. It says sulfur dioxide, which is SO2, is a gas that plays a central role in the formation of acid rain. And it's found in the exhaust of automobiles and power plants. So it's a pollutant, okay? It comes out of exhaust. Consider a 1.53 liter sample of gas of SO2 and at a pressure of 5.6 times 10 to the third pascals. Then it says, if the pressure is changed to 1.5 times 10 to the fourth pascals at constant temperature, what will the new volume of gas be? All right, what's our equation for Boyle's law? Somebody help me out. P1 V1 equals what, guys? P2 V2. Okay, perfect. Now what I like to do when I'm reading these problems is go through and underline what they give us. It says consider a 1.5 liter sample of SO2. And then it says it's at a pressure of 5.6 times 10 to the third pascals. So is that what it finally is, or is that what we started with? That's what we started with. So P1, which is the initial pressure, what are we going to put there? Good. 5.6 times 10 to the third. I'm just going to put a capital E. You know what I mean, right? 5.6 e to the third. And then put the units in, pascals. Okay, we're going to put that in parentheses. What was the initial volume? Yeah, it's 1.53 liters. So let's put that in. 1.53 liters. Include the units. You'll make less errors if you include your units. Okay? Well, all of that is equal to P2. Did it give us the final pressure? It did, right? 1.5 times 10 to the fourth pascals. So let's put that in. 1.5 e to the fourth pascals. That's P2. Did it give us V2? It didn't. And so what I always do is just keep it as V2. That's the variable that we don't know. You could call it X, you could call it whatever you want. That's what we're going to be solving for. Jen.
Isn't this like what we learned last year with the mass and base or something?
Good. We did this last year, if you remember, in the acid base chapter, M1 V1 equals M2 V2. You remember that? So it's a similar equation, but different variables. Very good. Okay, now before we solve this, guys, before we solve it, let's go through and kind of get an idea in our head what's happening here. We had a volume and we had a pressure. Did pressure change?
Yeah.
Did pressure go up or down? It went from 10 to the third to 10 to the fourth pascals. So pressure is going up. So pressure is going up. What do we think is going to happen to volume? It better go down, right? At least that's what we learned from Boyle's law. Let's see if it actually does. Okay, we've got an equation here with one unknown. How do we solve for it? Divide by what? Yeah, we want to get V2, guys. We want to get V2 by itself. So how do we do that? We have to divide by this number, 1.5 e to the 4th pascals. But it's an equation. Whatever you do to one side, you've got to do to the other side. So let's divide this side also by 1.5 e to the 4th pascals. Okay. What happens to the 1.5 times 10 to the 4th pascals right here?
Cancels out.
Yeah, anything divided by itself is 1. It cancels out. That's why we did it on that side. So V2 is the only thing left on the right side. So let's take this number, times it by this number, and then divide by this number and see what you get. You guys try it on your calculator. Hey, are you guys getting that V2 is equal to 0.57? 0.57 what? What's the units?
Liters.
Yeah, it's going to end up being liters. Okay, did our volume go down? We started at 1.53 and we ended at 0.57. So yes, it did go down just like we were expecting it to up here. Guys, it's easy, right? Isn't that easy to do? That's an easy problem, Boyle's Law. I want to bring your attention to one more thing. Pay attention. Now, there's some tricks to these problems. They're going to try and change things on you. One thing that they'll do to trick you a little bit is change the units. So that's why I always like to write the units down. If we look at this problem, guys, what happens to pascals right here? They cancel out. And what unit are we left with? Liters. So that's why when we wrote our final answer, we put liters in there. Now, one thing that they could do is give you the first pressure, the initial pressure in pascals, and the second pressure in atmospheres, or some other unit. Could you do the problem that way?
Yeah.
No. What do you have to do first?
Switch it.
You got to switch it to which one?
Whichever one you want.
Doesn't matter. But you've got to make sure your units on both sides are the same. Make sure your units on both sides of this equation are the same. Okay. Any questions on Boyle's Law? Let's review it. As pressure goes up, what happens to volume?
Goes down.
Down. Well, what if pressure goes down? Volume goes up. What kind of relationship is that?
Inverse.
Inverse. P1, V1 is equal to what?
P2, V2.
P2, V2. Okay, if you remember anything from Boyle's Law, it's that equation right there. Okay, good news. We've learned enough to do a worksheet in your workbook. So flip your book a few pages. The worksheet is called Boyle's Law Worksheet. Boyle's Law Worksheet. Remember, pay attention to the units. It's not that hard. Convert to similar units on both sides and you'll have it. Okay? Hopefully that helps.